Hey guys, okay, so this is stats day 1, graphing and analyzing statistical data. So this is actually a review for you guys, I think, but you can watch this video as many times as you need. You want a highlighter. So stats are numbers used to describe a set of data. A histogram, you've seen this before. It's almost like a bar graph. I say it's a bar graph, but it's like almost like a bar graph. Okay, you can think of it as a bar graph. Displays frequency distributions. It looks something like that down there. A dot plot, you've seen before too, displays frequency distribution using dots instead of bars. It looks something like this. And then box plots, diagram that shows the min, max, median, and interquartile range, IQR, of data. So it's been a while since you've done that, and then we're going to do one of those together. A scatter plot, a graph that shows correlation. So something like this would be a scatter plot. And sometimes it shows that there's no correlation, okay? A regression line is a line of best fit. That's what we usually call it. It's drawn using a scatter plot that has some sort of strong correlation. So if we look at this scatter plot, it's basically just like some dots, but it looks like the dots are going in this negative slope. So that would be our regression line. That would be our line of best fit. It could be that you have dots that go like this, and it kind of looks like a U, so it kind of looks like a parabola. So that is also a scatter plot, and that also shows some sort of correlation. If it's just all over the place, then it shows no correlation. Okay, a mean is an average. Its notation is X bar. So I forgot to put the bar on top, but it's an X bar. A median is the middle number. If there's two numbers in the middle, then it's the average of the two. So if you take the middle, if there's like 10 numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The middle numbers would be like 5 and 6 would be in the middle literally. So the median would be a 5.5. The mode is the number that occurs most. You can have more than one mode. And then variance, the average of the squares of the deviation, and deviation and variance helps determine dispersion. So standard deviation and variance have a lot in common. Standard deviation is the average distance the data is to the mean. So we'll talk about that a lot more later. But basically, variance is what you use to get standard deviation. Standard deviation is important. So one thing, like in college, let's say, your college professor might say, the mean was 50% and the standard deviation is 5%. So if you have a 50%, that's a C. If you have a 55%, that's a B. If you have a 60%, then that's an A. So that's standard deviation. It tells you the average distance the data is to the middle, the mean. Okay, so measures of central tendency. So this tells you something about the center of the data. So you have a bunch of data, a bunch of numbers, whatever it is. The mean, the median, the mode helps you identify the center of the data. So when people tell you what the average income is, or the median income, and that's in a lot of like, you know, facts and books and whatever. So that helps you identify what is in the middle of a whole bunch of data points. Measures of dispersion, that has to do with the range. So dispersion is like how when you disperse something, like you throw something and then there's like, it gets dispersed, right? So it tells you about the range from smallest to biggest. So is it a really big range or a really small range? So a measure of dispersion would tell you like the range in incomes, right? So a big range would mean that some people earn a lot and some people earn a little. Q1, Q3, so median. When you take the median of the first half of the data, that's actually Q1, quartile 1. And then when you take the median of the second half of the data, that's actually Q3. Variance and standard deviation, those two things tell you also about a measure of dispersion, like how dispersed the data is. Standard deviation looks something like that. It's almost like a swoop, you know? So that's generally what we use to show it. IQR is interquartile range. So interquartile range would be between Q1 and Q3. If you subtracted those, that's your range of the interquartile. It indicates how scattered a distribution is. So all of these indicate how scattered a distribution is. So this tells you about the center of the data. This tells you how spread out the data is. So there's three things that we always want to think about in terms of like data. So it's shape, the center, and the spread. I wrote speed, but it should say spread. There's like an R in here. Sorry. So the shape would be like symmetric or skewed. That would be the shape. The center, like this would be the center, whereas this would be the center. And then the spread would be how spread out the data is. So it just depends on, you know, the data. So I will say this is called symmetric when it looks like a really nice looking bell curve. This is really weird. This looks like everything's going to the right, but this is called skewed left. So the data is skewed left. I know it's really weird. It's like the opposite of what you think it is. So basically, one way to think about it, I don't know if I should say this online, but one way to think about it is these people, we don't really care about them for some reason, and we're caring about this stuff. So when you're skewed left, the people on the left are kind of screwed. So you're screwed left, okay? So this is called skewed left. In terms of shape, center, and spread, so if you add and subtract numbers to a set of data, like let's say there's test scores, and I add a 5 to all the test scores. Well, all the test scores are just going to go up 5, right? So like if it's from the lowest score was 70, the highest score was 90, then it would go from 75 to 95, but everything would just shift up a little bit. The shape would be the same. If you multiplied those test scores by 17 or whatever, it would become a bigger shape, but the shape would still stay the same. It would be like symmetric shape, right? So like similar, sorry, it would be a similar shape. The center of the data, though, if you added 5 to all the test scores, the center would move to the right, right? So the center moves when you multiply, divide, add, subtract. The center is going to move, okay? The spread, if I added 5 to all the test scores, the spread or the range is going to be the same because now it's 75 to 95 instead of 70 to 90. So the spread's the same here, but if I multiplied all the scores by like 10 or something, then it's going to get bigger, okay? So the spread is going to change when you multiply or divide. So that's what this chart is just kind of telling you. Okay, so using this frequency distribution right here to draw certain things. So a histogram might look like this. So if you're, age 12, how many people are age 12? That's what frequency means, right? How many people are 13? How many people in the classroom are 14? How many are 15? And then how many are 18? So this would be a histogram. You would have on the bottom the age, and then you would have the frequency this way because that's what makes sense. Like the frequency is like how tall. Like then you can tell, oh, there's more 13-year-olds, and then there's a lot of 12-year-olds, and there's not a lot of 16 or 17-year-olds. So you want the graph to make sense, and you want to label the y-axis and the x-axis. Okay, or a dot plot. A dot plot is basically the same. Okay, so it's just using dots instead of these bars. Okay, the scatter plot over here. So if we were to do like 12, 7, right? 12, 7, and then we would use points. So pretending that these are points and not frequencies, we could make these 5 points, and then the 5 points, we would look at it and be like, for a scatter plot, oh, that looks like it has like a negative slope, and then you would just like draw. Usually other data, not this, right? So you would draw some sort of regression line or line of best fit. This would have a negative correlation or slope. That's what we say about it because the slope is negative. Okay. And then example 2, given the data, draw a dot plot. Okay, describe the overall pattern of the distribution and any deviations from, why am I missing a word? Any deviations from the overall pattern, I guess, or any deviations from, what's happening. Okay, so it gives you age, and then it gives you number of texts. So you're going to write that down, and then let's say we counted like 10-year-olds, they send about 400 texts per month. 14-year-olds, it goes all the way to 1,700. And then 18-year-olds, it goes down a little bit, 1,200. And then 22-year-olds, they work and stuff, you know, so it's like down to 700 and so on, okay? So for a dot plot, you would have your H at the bottom. You would have, this is still, the number of text is still basically frequency. And then you would have that on the left side. And then you would do your dots. And then the dots in this form represents going by hundreds, right? So you don't want to do a 400 dots. So you say average number of text in hundreds. So then you can do your dot plot that way. When you describe it, you look at this and you're like, okay, there's 3 things I need to look at. I need to look at shape, center, and spread. Always when you're describing, you need shape, center, spread, and any deviations from that. So any like weird things also, okay? So the shape of the distribution is blank. You're always going to write something here, symmetric, skewed, somewhat. So when I look at it, it looks like there's more stuff going on the left side. So that's why I wrote skewed right. Okay, so there's more stuff going on the left side. It's skewed right. I said slightly. If you say slightly, if you say a little, if you don't, if you just say skewed right, that'd be fine. Okay, the center is at approximately, really you have to count to the center. So when I look at this and I say I count to the center, I'm going 1, 2, 3, 4, and then 1, 2, 3, 4, 5, like here. And then somewhere right in the middle would be 16. So you're counting to the middle of the dots basically, which would be like right here. So 16 years old. So the center is going to be the median or mean value, whatever is easiest to find. Usually it's the median. With a spread of, and then you just count the spread. So the spread of 26 years old all the way to 10 years old is 16, right? So the range is 16. So that's going to be some sort of range, standard deviation, IQR. So you want to mention the shape, the center, and the spread. Okay, number 3. Given the data, draw a box and whisker plot. So it's been a long time since you guys have looked at a box and whisker plot. Describe the overall pattern and any deviations from that pattern. There we go. So let's say this. You have a stem, or it's called a stem and leaf plot. This is already called something that's called a stem and leaf plot. This is when you go by like tens and units, okay? So this represents 71, 76, 76, 82, 83, 85, 91, 95, 97. So it represents all of those numbers. And then using those numbers, using these numbers, so there's 9 numbers total, we want to draw a box and whisker plot. For a box and whisker plot, we need multiple things. We need a min, a max, a median. So the min is easy, it's the smallest number. The max is easy, it's the biggest number. The median is the one in the middle. And then the one in the middle, if there's 9 numbers, so little, big, and then it goes like this. And then here's the middle number. 83 is the middle number, that's your median, okay? You do not include the median into quartile 1 or quartile 3. Quartile 1 is the median of the first quartile. So the first quartile, like the first half of the data, goes from 71 all the way to 82. I would go to 83, but 83 is already used in my median, so I don't include it. So here's 71 all the way to 82. And then the next number is 76, and the next number is 76, and then in between that is a 76, right? So I wrote actually the 4 numbers that we're taking the median of, and it's 76 right in the middle, so your Q1 is 76. Your Q3 is the median of the last half of the data, so from 85 all the way to 97. So I listed them out. I'm going to go in the middle, it's this number right here. This number right here is the average of 91 and 95, which is 93. Your range is the whole thing, 97 minus 71, so 26. Your range is 26. Your IQR is going to be your Q3 minus your Q1, which is 17. Okay, so that's your interquartile range. This is a quartile 1, quartile 3. Your interquartile range inside your quartiles is 17. Okay, so when you draw it, you have to draw some sort of number line, and you have to use like, you know, go by 5s, go by 10s, go by 1s, whatever you're going to go by, okay? And then you want a min, you want the max, you want Q1, Q2, Q3. Q2 is literally the median, so that's Q2, okay? When you draw it, you draw a box, and then you draw this line over here, and then you draw 2 whiskers on the side. So what this tells me, just looking at it, these look about the same size. This one, this would be the middle, so right now, I'm a little bit to the left, so I am skewed right. So your shape, right here it says the shape of the distribution is very slightly skewed right. So we want the center, the shape, the center, and the spread. So here's the shape. The center is at 83, I already know that because median is 83, with a range of 26 values, that's a spread. But then the spread for this also has an IQR. There's 2 ranges. There's this one and there's an interquartile range. So if we have both, we want to include both. So it has a range of 26 and an interquartile range of 17. And then right here I wrote just, for us to know that by definition, the way we found this was, this is half the data, this is half the data. This is the average of the first half. Not the average, this is the median of the first half. This is the median of the second half. So really, this is 25%, 25%, 25%, and 25%. There's 50% of the data inside the box, 50% of the data outside of the box, 25% of the data in each whisker. So just different ways to think about the data, and this is a different way to look at data. So you can really see like, oh, this is 50%, this is 25, this is 25, this is technically 25, this is technically 25. All right, so there you go. The homework is posted, and you're going to ask questions. If you have questions, good luck.